In section 5.4, we're going to be looking at medians of triangles. So what is a median of a triangle? A median goes from a vertex to the midpoint of the opposite side. So we're looking at line segments that go from a vertex to the midpoint of the opposite side. So kind of the first thing you want to do is, I guess I'm just approximating right now, I'm going to approximate the midpoint of the side. To prove it would be the midpoint, I would show congruent tick marks here. And now if I take my segment, and maybe I'll change the color here. If I go from this vertex to the midpoint on the opposite side, I've just created a median. And you can probably tell that we could have three medians in this triangle. We could go from this vertex to the midpoint of this opposite side, or from this vertex to the midpoint of this opposite side. Now once again, just like with perpendicular bisectors and with angle bisectors, we're going to have a point of concurrency. All three medians are going to meet in the exact same place. It is called the centroid. This we're going to do in class. You've already constructed perpendicular bisectors, and those will help you construct medians. Because if you think about it, a median goes from a vertex to the midpoint of the opposite side, but didn't perpendicular bisector, keyword bisector, already find the midpoint of that opposite side? So now that we have that midpoint, you're going to be able to easily draw your medians. The midpoint of this side is automatically where the perpendicular bisector went through, so another median goes from vertex to opposite side. And lastly, this perpendicular bisector, you knew the median was here, so you're going to draw the last median. And these are going to all be concurrent. Again, this part we'll do in class, but once you construct all three medians, they will meet at the same point. It's called the centroid. So this theorem is the concurrency of the medians of a triangle, that they do all intersect at one point. That point is called the centroid. And the cool thing about this centroid is that this point is 2/3 the distance from each vertex to the midpoint of the opposite side. Okay, I'll explain that a little bit more here. First of all, I want to point out that these are medians. That means that C is the midpoint of this side, and so this blue line is a median. F must be the midpoint of this side, so I know these are congruent. And this blue line is a median because it goes from vertex G to this midpoint F of this side. And finally, D is another midpoint of side BG in this case, so these segments are congruent. And our last median goes from vertex E to the midpoint D of the opposite side. Now notice how I said that this centroid, this point where all those medians cross, is 2/3 of the distance from each vertex to the midpoint of the opposite side, which means we split into two parts, 2/3 and 1/3. 2/3 is the distance from the vertex to the centroid of the whole thing, and from the centroid to the side is 1/3 of the whole distance. So if you think about it, if this is 1/3 of the whole thing, and this much is 2/3 of the whole thing, then the 2/3 segment is twice this segment here. Which means if I knew that this portion was 3, this portion of that median is 6, and the whole thing is 9. Notice that 3 is 1/3 of the total, or 9, and 6 is 2/3 of the total, or 9. The same applies for every median. In this median I have x and 2x because let's say now that I knew this longer portion from vertex to centroid was 10. That was 2/3 of the total. This is only 1/3 of the total, so it's half of the 2/3 portion. If this is 10, this is 5. That's why I said x and 2x. And notice what would the whole length be of this median? It'd be 15, right? 10 plus 5. And 5 is 1/3 of 15, and 10 is 2/3 of 15. And finally, let's say I knew the entire length of this median was, how about 12? If I knew this entire length was 12, then this portion is 1/3 of that. And 12 divided by 3 would be 4. And this portion would be 2/3 of 12, or double this, which would be 8. And notice 4 and 8 do add to the total that I said of 12. So we have this situation where we have, anytime you go from the vertex to the centroid, it's 2/3 of the total centroid length, or total median length. Anytime you go from the centroid to the side, it's 1/3 of the entire median length. And I want to show you this in Geometry Sketchpad. All of these blue segments are medians. They're going from a vertex to the midpoint of that opposite side, vertex to midpoint opposite side. And notice the numbers that you see from centroid to C is 5, centroid to B is 10. Yep, this portion is double this portion. Here again, another median, centroid to D is 5.4, centroid to E is 10.8, or double that. Centroid to F on this median is 6, centroid to G on that same median is 12, again, double that. And that case will be the same no matter where I move. Now it should make sense, the centroid is always going to stay in the inside or the interior of a triangle. It can never be outside of that triangle. Alright, so let's summarize here what we know. Oh, just kidding. We're going to do a cool experiment in class. This is actually the neatest thing you can do, is we're going to cut out a triangle, and the centroid is actually the balancing point of the triangle. It's the center of gravity, so you can put your pencil right on the centroid and balance your triangle there. We'll do that in class. Now, summarizing everything we know about that centroid. First of all, it was the point of concurrency found by constructing the 3 medians of the triangle. As you're going to see in class, it's the center of gravity, or the balancing point, which is cool. It is always inside the triangle, and it splits that median into 2 parts, where the portion from the centroid to the side, to the midpoint of the side, is 1/3 of the total, and the portion from the centroid back to the vertex is 2/3 of the total. So that's everything we know about the centroid, found by doing medians. It's a balancing point, and it splits the median itself into portions that are 2/3 and 1/3 the total. This example uses that 2/3, 1/3 business and what we know about medians here. There are 3 paths through a triangular park. So this is the outside of our park, and the blue lines are paths through the park. Now it says each path goes from the midpoint of one edge to the opposite corner. So that means S is the midpoint of this edge. So these are congruent, and it goes to the opposite corner. Well, what does that make this blue line? A median, right? Because it goes from the midpoint of a side to the opposite vertex. So the blue lines in this case are medians. And then what would that point P be called? Hopefully remember, we've been talking about the centroid is where the medians meet. So each of these medians is divided into 2/3 and 1/3 segments. We're going to use that in a minute here. Oh, all of these paths go from the midpoint of one edge to the opposite corner. So T is the midpoint of BC, meaning these are congruent. Another median. R is the midpoint of AC, meaning AR and RC are congruent. And another median. Alright, let's see what we got here. I'm finding a lot of lengths. I start out knowing that SC is 2,100 feet. SC. Okay, notice that's the entire length here is 2,100. And I know that this portion is 1/3, this portion is 2/3. So the first thing you're actually going to do, since 2,100 is the entire length, you're going to divide it by 3. That'll give you this 1/3 part. And then we're going to double that to get to the 2/3 part. So 2,100 divided by 3, 21 divided by 3 is 7. So P to S is 700. It's 1/3 of 2,100. And then P to C is double that. 700 times 2 would be 1,400. And notice this is correct because 700 plus 1,400 is 2,100. Alright, what do we got for the next one here? BT is 1,000 feet. BT is here. 1,000 feet. Oh, you know what? I should put my labels of feet here. Sorry. BT is 1,000 feet. My apologies. Find TC. What is TC? Well, because T was the midpoint of this side, we knew that this segment BT was congruent to this segment, TC. So this must also be 1,000 feet. And what is BC? Now BC is this entire side, or that entire segment. It should be double this 1,000, or 1,000 plus another 1,000. So, just kidding, 2,000 feet for that total side. Alright, what is PA and TA we need? Knowing, okay, PT is 800 feet. Where is PT? That's right here. This is 800 feet. Alright, this is part of a median. It goes from that centroid to the side, to the midpoint of that side. If that's 800, from the centroid back to the vertex is double that. 800 times 2 would be 1600 for PA. 1600 feet. So what is TA? TA is the entire segment, 1600 plus 800, or 800 times 3, and we get 2400 feet. And finally, BP is 1400 feet. BP, so this segment is 1400 feet. Now this is a part of the median from the centroid back to the vertex. I know from the centroid to the midpoint of that side is half of this distance. 1400 divided by 2 is 700 for PR. And then BR, which is the entire median, would be 1400 plus 700, or 700 times 3, which is also 2100 feet, like this median. Alright, so working with medians today, intersecting at the centroid, and noticing that we split the median into parts that are 2/3 and 1/3 of the total.